So you're sitting in a system design interview and the question is, design a social media scheduler. What do you do? In this video, I'm gonna break down how I would answer that question using a real-world project that is the one that I'm currently working on. And also, along the way, I will show you how to think like a senior software engineer. My name is Lorenzo. I'm a software engineer and I'm building my first end-to-end application just for fun. The idea? A content manager where you can schedule once and post across all your social media platforms. I'm doing all of this for fun, but I hope one day my app will be used by a large pool of content creators. Thank you so much for clicking on this video and I hope you stick around for the ride. System design interviews are pretty common when you reach a certain level of seniority as a software engineer, but they can also be intimidating because they're generally open-ended and there is really no right or wrong answer. So in this video, I will show you my approach to system design and I will do it in a format that is a mock system design interview. System design is not really about coding, it is more about the solution that you're able to provide and to come up with. Interviewers are generally more interested in your thought process rather than the solution itself. They want to see how you approach real-life problems with a real-world solution. So in my case, as a mobile engineer, the goal is to provide a solution that is robust, scalable, testable, and ultimately providing a piece of software that is capable of, for example, networking, caching, making asynchronous requests, persisting data, handling offline capabilities, etc., etc. The bottom line is that you do not just master system design interviews by memorizing the solution because there is no one solution that fits all. You master it by learning to understand the requirements, the constraints, and come up with the best solution according to the trade-offs you have, because there will always be trade-offs. There is no just one best solution, and generally the interviewer is not even looking for that. What they're looking for is if you are capable of surfacing all the problems, all the trade-offs, and all the constraints that can come up with a specific problem. And according to that, design the best solution. But enough talking, let's get to it. Okay, so let's get started with the simulation of this system design interview. As I said before, system design interviews are generally not really an interview. They're more like a chat, a discussion over a specific topic. This means that generally there is no really a good or a right or wrong answer. And usually the interviewer wants to see what your thought process is, where you're able to guide the conversation, what are the topics that you bring, what are the trade-offs that you identify, and how you deal with each of those. You're not really required to provide a specific solution. You just have to come up with a very good architectural design and a good understanding of the problem and what are the trade-offs that can be bottlenecks in this design. Especially identifying which solution could be better and why you pick one solution instead of the other and so on. This is also why generally system design questions are open questions, they are broad, because it is up to you to identify all the constraints, to define all the requirements, define the specifications, and come up with a solution. So for example, let's get started here where the prompt for this system design interview is design a social media scheduler. So I will start giving you the framework that I use for this kind of interviews that I think is pretty much the standard when it comes to these interviews. The way I like to start is by containing a little bit more the broad prompt that I'm given. This means identifying a few requirements that can be functional requirements, non-functional requirements, and making assumptions about what can be in scope and what can be out of scope. The idea here is to provide basic functionalities, let's say, to come out with an MVP. So what would an MVP look like? In my case, I would like to design the social media scheduler with these minimum functional requirements. As a user, I want to be able to connect my social media accounts. That can be, of course, there's going to be Instagram, X, Facebook, TikTok, YouTube, whatever. Once I have my social media account connected, I want to be able to upload media. Upload media, in this case, means literally picking media from my camera roll and importing it into my app. One first trade-off that I want to identify here is I don't mean uploading media to a backend system or a CDN, anything like that, because I don't want to occupy too much space in the cloud or CDN or whatever. So I'm deciding here that media will be saved locally. And the reason here is because we could just hold a reference to the media in the user's phone gallery, but what if the user deletes that media and still wants to post that media on their social media? So what I'm thinking is I will save that media locally in this my app sandbox, and one trade-off is that I may duplicate storage because I have that media stored both in the camera roll and in the app sandbox. As we said before, these are trade-offs. Where do you want to occupy that space? Do you want to occupy that locally, or do you want to occupy that remote CDN, cloud, or whatever? For cost reasons, I prefer to have it locally because it costs nothing. Next feature is creating a post. So basically I want to attach one of those media to an actual post, being able to schedule it, and then I want to be able to view, edit, and cancel my posts. This could be, I don't know, a list view, a calendar view, but I just want to give the users the ability to view, edit, and cancel their posts. Some non-functional requirements are, as I said before, optimized for cloud storage, and we already discussed this. And this goes along minimizing data consumption, because if you are on a Wi-Fi, that's fine, but if you are using cell data and you're uploading media, images, videos in bulk, that could be heavy on your data. So that's why I still prefer to keep storage locally rather than uploading on an actual backend service. Also, I want to have some sort of offline support. I imagine if a user doesn't have internet capabilities at the moment, I still want to be able to persist data so that they can see all the posts and all the media that they've created or uploaded till now, although they may not have the ability to interact with it until the connection is back. And here I'm thinking about implementing notifications. Let me remove the misspelling here. And I put a question mark here because maybe I'm thinking, what do we want as notifications? We want to be notified after we schedule a post when that post is actually posted. Or maybe we want to be notified if a scheduled post has an error and doesn't get posted for any reason. Those could all be valid use cases where we want notifications. And also, this is a good time to make some assumptions. For example, what do we want out of scope, meaning we're not going to consider in this discussion. For example, let's leave out localization for now, let's leave out analytics, and let's leave out authentication. Let's consider that users are already authenticated, so we would not consider that. After this introductory discussion about functionalities, requirements, and so on, I like to move to designing the data model. This gives us a good representation of the entities we're going to be working with. In this case, we're going to be working with a data model for users, data model for posts, and data model for social media account. Of course, this is just a minimal representation. In real life scenario, these models will have many more fields, many more properties, but for the sake of this discussion, let's stick with the minimum requirements needed. So for example, a user will have, sure enough, an ID, a username, all the connected accounts, and this will be an array of social media, meaning an array of this object down here. They will also have an array of media, meaning all the media that they have uploaded or saved locally in the app sandbox. And usually you want to have an array of URLs. You don't want to have the actual data of the media embedded in this field, because otherwise this object would be a bit heavy. And same for the posts, actually do not really contain any heavy objects, so we may be good just storing the array of objects instead of the IDs, for example. But that is sure required for the media. Next entity is the post. Posts will have an ID as well. They will also have an array of media, meaning all the media that are attached to that post. Think of we're uploading a reel. These will likely be an array of just one object. If you're uploading, for example, a carousel, this could be an array of 4, 5, 6, 10 URLs. This will be the caption for the post. The scheduled date will be indeed the date where you want this post to be posted. And let's also consider a status variable, which is technically an enum. And the possible cases could be scheduled, pending, published, and error, so that we can track the status of this post. And last, it would be social media account, and this would represent all the social media accounts that the user has connected to their profile. Of course, you would have an ID as well. You will also specify what platform you are connecting, as I said before, like Instagram, X, Facebook, LinkedIn, anything. And we will need a way to store the connection, and that is usually done with the access token, and it will be just simply a string. So these are the entities that we will be working with. Once we have a good definition of these, I like to move towards a little bit of architectural design for our app. This is just like a very basic system architecture design. It can be as complex as you want. I like to keep things simple and discuss each decision I make in detail. Although here, I'm probably gonna go a little faster. So here, I usually mark the separation between front-end and back-end. So anything here is front-end and anything here is back-end. So on the backend side, we will need a server that accepts all our requests and implements all the APIs. Maybe a push notification provider and a CDN. I consider the CDN separate from the rest of the backend for the simple reason that it could be any third-party service that you could use as a CDN, but that doesn't really matter as much. On our front-end side, all these components will talk to an API client. And this is usually a network layer that interacts with the backend APIs and the CDN. Technically, it does not really interact with the push notification provider because the push notifications are sent directly to your app, at least in the iOS framework. So this arrow here is just representative. It doesn't really communicate with our API client. Your API client response will feed the data model, so what we've seen before. And the data model will be persisted locally as in a local storage for both caching and offline capabilities. Some key considerations here are the design points you want to focus on. For example, I always like to specify what sort of dependency injection mechanism I want to implement. There are many. Usually one of my go-to approaches is to use Swinject, which is a commonly used framework in the iOS development. You can create your own container, you can use different approaches. Swinject is one of the ones that I feel most comfortable with. So once again, there's no right or wrong answer. So as long as you can justify why you're taking one decision over the other, I think that's fine. Dependency injection goes along pretty well with the protocol-oriented design. So for example, I think it's worth mentioning that if you pair dependency injection with protocols, that is very useful to implement what is called separation of concern, meaning that each component of your software is independent from the other and can be interchanged very easily through dependency injection and protocol. Typically, one example is unit testing. When you're implementing unit tests, you usually replace components of your code with mocks. And you can do that very easily if you've implemented everything with protocols and dependency injection. Another key point to mention is your architectural decision. There are many patterns that you can implement, MVC, Viper, anything. Generally, when I go with SwiftUI, my go-to choice is MVVM. I'm going to implement MVVM with a coordinator, which seems to be pretty much the standard now. So all these objects here will communicate with the coordinator, and the coordinator will be responsible of taking care of the navigation, although here I just specified one view and one attached view model. Let's assume that you have multiple view models. The coordinator will be responsible of handling the navigation between all the views. The views is what is gonna be responsible for communicating with the user, so user interaction will go through the view, and the view model will do pretty much all the business logic. So this is a typical design pattern in SwiftUI. Next, some key points that I think are valuable in this discussion are all the trade-offs and all the possible choices that we could have for data storage. Once again, we want to store user information, for example, posts and media. I want to store them locally so that they're accessible even when there is no internet connection available. So let's analyze, for example, all the possible solutions that we have for data storage. Of course, we have key value storage, for example, like user defaults or property lists. And the pros and cons here are as indicated here. They're very simple to implement, but they're not really secure. They don't have a validation schema, and there is really no support for queries. So if you want to filter, if you want to query all your locally stored posts, this solution is not going to be the best. You can implement a database, which is a good solution for a large amount of data. It also helps with relational mapping, query system, and eventually data migration if you need. Cons are it is a little cumbersome to set up, and it is non-secure as well, meaning if you are storing sensitive information, this is probably not the best solution. But once again, are we really storing secure information that need to be encrypted here? I don't think so. Maybe just the access token needs to be encrypted. So for all the posts, all the profile information, maybe we could use a database, and just for the access token, we could maybe use the keychain. So once you list all these trade-offs, I think you're doing a good job. Also, another solution could be to implement our custom data storage. Pros, of course, it is highly customizable. It should be really performant, because if you design it on your needs, it will be very performant. But on the cons side, there is maybe a longer setup because you have to build it from scratch. Whereas if you use, for example, Swift Data, it comes already implemented, you just have to consume it. And of course, there is the cloud option, which I already ruled out because I don't want to occupy too much space on a backend. So in this case, I would just mention it, but I would also once again specify that this is not my primary choice. After this, I think it would be a good time to start discussing some API contracts. Something really useful would be what kind of API you would like to adopt. You can mention all the options that you know, for example, the traditional REST API, you could use GraphQL, you could have push notifications, and for each of those, you can also discuss if they support pagination. You can also define, you can also discuss what types of pagination and which one works best for your solution. Why would you pick one or the other? And also discuss why you would pick REST over GraphQL or vice versa. In this case, let's go the easy route and let's use REST API as a choice. So in our case, this is a very rough sketch of what the app would look like. Technically, you're not required to give a UX representation of your app. I think just like something like this works because you just have to make the interviewer understand what your thought process is. You're not asked to build a UI. You're not a UI designer. So just maybe saying that there is a button where you connect your social media and this button triggers an API call, I think that would be enough. For example, this button here would trigger a post call to the connect endpoint where you pass as a body social media account. And the social media account is the data model that we saw here. So in this case, the server takes care of connecting the user profile to their social media account and returns a connection, basically an access token, that we use in all the other calls. Also, when it actually comes the time to schedule a post, where that is when we will actually upload the media. So we will pick one of these objects, a post object, from our local storage and actually upload the media to the backend along with the post object. So the caption, the schedule date, and so on. We will call this post, which contains the media in the body, and we will also call another post endpoint, let's call it schedule, where we will pass the post object. So this post object will contain the schedule date, the caption, and maybe what platforms we want to post it on. And then we also want to have these endpoints because, as we said before, we also want to see, edit, and cancel all the posts that we have already scheduled. We can actually disregard this. This is just like a duplicate. Let me remove it. So this would be just a very simple and basic API interaction. But I think the important thing here is to showcase that you have a good understanding of how all these mechanisms work and interact with each other. Now that everything is pretty much done, you maybe want to give a little bit of a recap maybe, or another good thing would be to drive the discussion towards anything else that you could have leave out. For example, performance optimization, memory management, anything like that, so that you could really come full circle through all this entire discussion. So this was a really quick simulation of a system design interview. Of course, I didn't dive as deep as I would in an actual interview. Otherwise, this would last 1 hour. But this was just an example for me to show you what my approach is and what is the framework that I use when I attack these kind of problems. I hope you got some value out of this video. Once again, this is not meant to be like a fully comprehensive simulation of an entire system design interview, but at least now you have pretty much a good idea of what my framework is for this kind of interviews. Full simulation would last for maybe 1 hour, so I didn't want to make a 1 hour long video, but at least this is a good start. So from now on, what I'm gonna do is I'm gonna start the development process for the mobile part of my project. And this is gonna start with the UX UI portion of the project. And I'm gonna do that using UX Pilot, which is a UI tool that leverages AI to build wireframes and actual mobile UI. Basically, what I plan to do is using ChatGPT to refine the features and the requirements for my project and use that to feed my UI UX project in UX Pilot. And this is gonna give me as an output all the wireframes, pages, and design system that I need for my mobile app, starting from the UI. And that's what I'm gonna share in the next video. So see you next.